everyone. I am Dr.J Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss the topic expected frequencies of binomial distribution. See, that same topic, expected frequency, we can discuss in binomial distribution, similarly, Poisson distribution. Actually, what is mean by expected frequency? See, consider any random experiment like tossing a coin, having n trial, tossing 4 coins, in that case n equal to 4. And this same experiment, it is repeated 100 times, that is capital N equal to 100. In that case, we can find out expected frequency. Any random experiment having small n trials and it's repeated capital N times. Suppose, I will give you example, 4 coins are tossed and the same experiment repeated 1000 times. 4 coins are tossed is a random experiment. It is repeated 1000 times. So, in that case, the number of trials small n are 4 and repeated times is capital N. For this, we can find out expected frequency of getting exactly x successes, getting number of successes. The formula is capital N repeated times into probability of capital X equal to X. Probability of getting number of successes. So, expected frequency formula for binomial distribution is capital N into, but binomial distribution probability of X equal to X formula NCX P power X Q power N minus X. So, you remember that expected frequency formula is capital N into P of X equal to X. In case if it is binomial distribution, P of X equal to X will be changed. If it is Poisson distribution, P of X equal to X is e power minus lambda into lambda power X by X factorial. Okay. We'll do one problem on expected frequency by using binomial distribution. The problem consists of 6 coins are tossed simultaneously. At a time, we are tossing 6 coins. That means small n equal to 6. How many times the 6 coins are tossed? For 6,400 times. That means it is repeated 6,400 times. So that means capital N, repeated number of times of capital N, 6,400. Now we need to find out expected frequency formula of heads. The success is heads by using binomial distribution. What is expected frequency formula? Capital N into P of capital X equal to X. But binomial distribution mentioned that small NCX P power X Q power N minus X. N, small n, we know. Capital N also we know. Small x, P, Q, we don't know. P means, the probability of success in a single trial. When a coin is tossed, what is P? 1 by 2, getting head. Q, 1 by 2. And small x is, depends on the capital X. What is capital X? We are going to find out expected frequency for what? For getting head. What are the small x values? If 6 coins are tossed, what are the possibilities of getting head? Maybe 0 heads out of 6 coins. Maybe 1 head, 2 head, 3 head, 4 head, 5 head, 6 heads. So these are the small x values. All values we have. Now we can find out expected frequency by using binomial distribution. This is the formula. Now, first we need to find expected frequency of getting 0 heads. N into P of X equal to 0. Small x equal to 0. That is capital N is 6,400. NCX, where small n is 6, C small x is 0, P 1 by 2 whole power 0 and Q 1 by 2 whole power n minus x. If you simplify, we'll get 100. That means expected frequency of getting 0 hits is 100. That means out of 6,400 times, if we coin 6 coins are tossed, 100 times we may get 0 hits. Out of 6,400 times, if the random experiment is repeated, 100 times we can get 0 hits. Now you find out expected frequency for 1 head, 2 head, 3 head up to 6 head by using the same formula. Expected frequency of getting 1 head, that means n into p of x equal to 1. Capital N 6,400 into p of x equal to 1 by using binomial distribution. 6c1 1 by 2 whole power 1, 1 by 2 whole power 5. If you simplify, 600. That means out of 6,400 times, 600 times we are going to get head. 1 head. Similarly, you can find out expected frequency of getting 2 heads. That means n into p of x equal to 2. Where capital N is 6,400, 6c2 1 by 2 whole square 1 by 2 whole power 4. We get 1500 times. Out of 6,400 times, 1500 times we are going to get 2 heads. Now we can find expected frequency of 3 heads. That means capital N into p of x equal to 3. 6,400, p of x equal to 3. What is the formula actually? NCX, p power x, q power n minus x. 6c3, 1 by 2 whole power cube, 1 by 2 whole power n minus x, 6 minus. We'll get 2000 head. 2000 times out of 6,400. Out of 6,400, 2000 times we may get 3 heads. Similarly, expected frequency of getting 4 heads. That means n into p of x equal to 4. By using binomial distribution mentioned in the problem, you can use binomial distribution formula here. NCX, p power x, q power n. If you simplify it, we'll get 1500. Similarly, expected frequency of getting 5 heads. That means n into p of x equal to 5. 6,400 into 6c5, 1 by 2 whole power 5, 1 by 2 whole power n minus x. 600 times. Now finally, expected frequency of getting 6 heads will get 100 times. Therefore, after getting expected frequency of all the successes, you can draw the table with x, random variable, 0 to 6. Why we have taken 0 to 6 here? If we toss 6 coins are tossed, what are the possibilities of getting head? Either it may be 0 heads, 1 head, up to 6 heads. Now expected frequency, we got it, 100, 600, 1500. If you add all these terms, we'll get 6,000, total 6,400. This means 6 coins are tossed 6,400 times. The probability of getting 4 heads is 1500 times. The probability of getting 6 heads is 100 times. The probability of getting 0 heads is 100 times. Okay? Now, similarly, we are going to take another problem to find the expected frequency by using same binomial distribution. 4 coins are tossed, small n equal to 4. How many times? 160 times. So capital N equal to 160. Fit the binomial distribution of getting number of hits. Fitting or expected frequency, both words are same. Fitting the binomial distribution is nothing but expected frequency of binomial distribution. For what? Getting number of hits. So capital X is getting number of heads. Tell me small x values, getting number of heads. If we toss 4 coins, it may be 0 heads, 1 head, 2 head, 3 heads, or 4 heads. That's it. And P and Q also required probability of success in a single trial, P. So if 4 coins are tossed. You consider only single coin. What is the probability of getting head? 1 by 2. Q also 1 by 2. Now by using expected frequency of binomial distribution, this is the formula. Now you find out expected frequency for 0 heads, 1 head, 2 head, 3 heads, 4 heads. First we need to find out expected frequency of 0 head. That means capital N into P of x equal to 0. Capital N is 160, P of x equal to 0, NCX, N equal to 4, C 0. 1 by 2 whole power 0, 1 by 2 whole power 4 minus. If you simplify, 10. That means out of 160 times, we may get 10 times 0 heads. 1 head. Expected frequency of 1 head. N into P of x equal to 1. Where N equal to 160, 4C1, 1 by 2 whole power 1, 1 by 2 whole power 4 minus 1. Because small x equal to 1. 40. Similarly, we can find expected frequency of getting 2 heads, 60. Expected frequency of getting 3 heads, 40. And expected frequency of getting 4 heads, 10. So, after this, we can draw the table with the random variable and expected frequencies. Add all the terms, we'll get 160 capital N. This means, if 4 coins are tossed 160 times, we may get 4 heads 10 times, 3 heads 40 times, 2 heads 60 times, 1 head 40 times, 0 heads 10 times. Okay? Like this, we need to find out expected frequency of binomial distribution. Now, third problem, fitting the binomial distribution means same expected frequency, but here coins and values are not given. Just a table is given, frequency F table is given, X values are given and F values are given, and N is given, small n, 6 trials, but P, Q not given. We need to find out how to find, sir. Actually, fitting of binomial distribution is nothing but expected frequency. N into P of x equal to x. Capital N, we know that total frequency. P of x equal to x in a binomial distribution is NCX, P power x, Q power n minus x. Small n, capital N you got it, 200. Small n from 0 to 6, no, down take 7 because it is not the countable. It is a random variable. 0 heads, 1 head, 2 head, like that 6 heads. N equal to 6. But P and Q we don't know. In the previous problems, in a tossing a coin, we can identify very easy P equal to 1 by 2, Q equal to 1 by 2. But here it is not a tossing a coin or throwing a die. It just table is given with the frequencies and x values. We need to find out expected frequencies. How? See, very simple. If you know f and x, you can multiply fx, f into x, then you take sigma summation by division sigma f. This is f, sigma f is 200. This is nothing but mean. In 10th standard, we have discussed, if you know the frequency and x values, sigma fx by sigma f is mean. But in binomial distribution, mean equal to NP. After getting this value mean by using this table, that mean value you can equate with NP in a binomial distribution because we know that mean equal to NP. N value you know that. From this we can find out P. After getting P, we can find out Q value. Then you substitute in this form for expected frequency. Got my point? If you know X and F, you find out Fx. This into this. 0 into 13, 0. 1 into 25, 25. 52 twos, 104. 58 threes, 174. 32 fours, 128. 16 fives, 80. 4 sixes, 24. Add them, sigma fx 535, sigma f 200. So mean equal to sigma fx by sigma f formula 2.675. This mean equal to in the binomial distribution which is NP. This 2.675 you can equate with NP. But NP you know that na, from the problem P. 6P equal to 2.675. From this we can find out P equal to 0.445. If it is 0.445, Q equal to 0.555 because P plus Q equal to. So capital N we got it, small n we got it, P also we got it, and Q also we got it. But finding P and Q is different compared to the first two problems in this session. After finding all this, we can find out expected frequency or fitting of binomial distribution by using this formula. From where to where? 0 to 6. 0 to 6. So n into P of x equal to 0, 200, 6C0 because small x values 0 to 6. 6C0, 0.445 volt to the power of 0, 0.555 volt to the power of 6 minus 2. If you simplify by using calculator, we can get 5.84. And expected frequency for 1, P of x equal to 1, 28.12. Expected frequency for P of x equal to 2, 56.36 by substituting P, Q values. Similarly, we can find out P of x, n into P of x equal to 3, n into P of x equal to 4, and n into P of x equal to 5. Lastly, n into P of x equal to 6. All expected frequencies, we got it. Again, you draw the same table. X and F values, these two values are given. We are finding expected frequency. 5.84, 28.12. Even if you add all these terms, we will get same value 200 like frequency value. In the problem given that expected frequencies, we have done expected frequency. Only frequencies are given. We have done expected frequency. Right? So finally, expected frequency formula capital N into P of x equal to x. This expected frequency we can do it by sometimes binomial distribution, sometimes Poisson distribution. In case, if you find out expected frequency for binomial distribution, you replace binomial distribution formula instead of P of x equal to x. What is that? P of x equal to x, NCx, P power x, Q power n minus. Sometimes we can do expected frequency by using Poisson distribution. In that case, P of x equal to x is e power minus lambda, lambda power x by x factor because it is a Poisson distribution. And one more last point, expected frequency also known as fitting. Fitting of binomial distribution or fitting of Poisson distribution. Okay? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.